Hello everybody to Math with Mike. This is week 1, April 6th to 10th, the answers for the 10 question quiz. So let's get into it. The first question, question 1, is 20% of 420. So in 20% of 420, what we actually want to find first is 10% of 420. Now what's that going to do? Or how do we do that? When you have a number, we know 420 has a decimal point here, right? Because 420 is 0, 0, 0, 0. That keeps going forever. So 10%, when you take 10% of something, you actually move the decimal point one space. So I moved it one space to the left. I essentially made the number smaller. So it went from 420 to 42 because that 0 got replaced. Now, if I had equally done an 8 here, that would be the same except I'd have 42.8 because here the decimal point is here. Here the decimal point moved one to the left. So this is now smaller. So 10% of 420, let's change that back. 10% of 420 is 42. You can write 0.0, or you can just drop that because it's understood and implied. So again, 10% is 42 of 420. Now, what we actually asked was 20%. So 20% of 420, well, we did 10%, and so that's 10%, and if that is 10%, then what is 20%? Well, it's just double, or times 2. We double 10 to 20%, so we double 42, and that gets us 84, because we doubled 42. So, at the end of the day, 20% of 420 equals 84. So that's the answer there. You could do 5%, which is halving 42. That would be 21 would be 5%. So we get that 10% first. So that's question 1 and an answer there. Question 2. So, question 2 is actually 508 times 100,000. We want to count zeros essentially here. That's the trick, the whole trick, and there's not really a major trick to this. But there's 1, 2, 3, 4, 5 zeros. And so since there's 5 zeros, we actually add 5 zeros to the end of this. So we go 508, 0, 0, 0, 0, 0. That's 5 zeros. So that's the number that we need. And then if you want to be really good, you can put in commas every 3 starting from the left. So you can go 3 over, comma, then 3 spaces over, comma. And that allows us to read this more easily, right? Because our places are now delineated. So we know these are the hundreds, we know these are the thousands, and we know these are the millions. So how would we read this number? 50,800,000. So 508 times 100,000 is actually 50,800,000, or just this number with 5 zeros after it. And make sure that you count those zeros. So that was question 2. Question 3. Now this question has to do with bringing together like terms, or things that basically look the same. So we've got 10x minus 10 minus 11x plus 11. Okay, these plus and minus signs are super important So there's an implied plus sign here, so I'll just write a tiny plus. So we bring together like terms. What does that mean? Well, this is a number and this is a number. So let's put them on the kind of the same end of this and put them beside each other, this one and this one. Then over here we've got 10x plus 10x minus 11x. So what I did was I just switched basically these two terms. So that one over there, that one over there. And now this chunk of stuff and this chunk of stuff, I can actually resolve them, right? Meaning they can come together. So 10x minus 11x, well, that's actually minus 1x because I had 10 things and I took away 11, so I owe one thing. Then minus 10 plus 11, well, if I owed 10 things and I was given 11, I actually still have 1. So the answer to this is minus, well, we can just say x, because that 1 is implied, plus 1. And that's our answer there. So we put the like terms beside each other, we brought them together, slash like added them or subtracted them, making sure to watch our signs, and then we created and finally got to this. So minus x plus 1 is the simplified form of that. So that's the answer there. To question 3. To question 4. This is testing our exponential skills. So x squared times x to the third times x to the fourth. What does that equal? Well, if I have x squared, it's actually x times x, right? Because something squared is just it times itself, times, and then x to the third, well, that's actually x times x times x, times, well, and x to the fourth is just x times x times x times x. That looks long and annoying, but these exponents actually tell us how many times this thing is multiplied by itself. So if I have a whole string of the same thing being multiplied, that's just another way, an easier way to write it as an exponent. So I just count these, essentially 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 x's, so I've got x to the 9th. Now the cheater way to do this, when these numbers get more complicated, is actually, you'll notice, 2 plus 3 plus 4, well, that equals 9. So when exponents are when the same base, that's base is x here, with an exponent is multiplied to get the simplified version, you add all the exponents, you add them. And in future videos and in future problems, you're going to have to multiply these, or you might have to do other things to these, but if the bases are multiplied, you add the exponents. Now the bases also have to be the same. Keep that in mind. So that's question 4. Question 5. Question 5 has to do with trigonometry, which sounds scary, but it's really not. This triangle you should memorize. This triangle is super, super famous. Why? Because in this triangle, there's 60 degrees and there's 30 degrees. If this side is 2, this side is 1, this side is root 3. That might sound confusing, but again, square root is just a function that you can hit on your calculator. So you can basically go 3 square root it, and it'll give you a number that's like 1.3 something. But for now, we don't want to like list out this massively long decimal point, so we just leave it as root 3. So the question that I asked was cos of some angle equals adjacent over hypotenuse. Okay, what the heck does that mean? Well, if this is the angle, the adjacent is right beside. The hypotenuse is always the longest. And then the opposite is across from, or opposite this angle. So if this is adjacent, this is opposite, and this is always the hypotenuse no matter what. It's across from, the hypotenuse is across from the right angle. Then the adjacent, literally, of 60, so cos of 60, we need that angle. We need to know which angle we're talking about. Cos of this, 60 degrees, is adjacent. So it's literally just, what is this side length? 1. And then over hypotenuse, what is this side length? Well, that's 2. So 1 over 2 is the answer. So cos of 60 degrees is 1 over 2 for this triangle. And so I could just as easily take cos of 30 degrees. Now that changes because now this is my angle. So cos of 30 is going to be adjacent, root 3, over hypotenuse, root 3 over 2. So those both stay true. Cos of 60 is 1 over 2. Cos of 30 is root 3 over 2 because I used the different sides in this triangle. So all you're doing is just getting this for those answers. So that is question 5. Now question 6. Question 6 is x plus 3 over x minus 1, or sorry, not over, times x minus 1. This is the distributive property. So everyone should remember that you multiply this times this, this times this, this times this, and this times this. So we're going to get 4 boxes at the end of this. That's going to be the multiplication of all these things. So x times x is x squared. That's the first one. Then x times minus 1 is minus 1x. 3 times x is 3x. And 3 times minus 1 is minus 3. But the trick is these two things are like terms. So there's no other x squareds here, there's no other numbers, but there are these like number x, right? Negative 1x, 3x, there's an implied plus there. So what's negative 1 plus 3x? Well, that's 2x plus 2x is the answer there. X squared plus 2x minus 3. And don't forget these signs. These signs are really important. So we multiplied this out. We got 4 things, and the middle ones brought together to make one thing. So we have 3 things. That's our answer. This is a quadratic. That's going to look something like this. Just so you know. And you can start thinking about that. Okay, that was question 6. Question 7. Subtraction of fractions. So we have 1 over 2 minus 3 over 8. Well, 1 over 2 is the same thing as 4 over 8. How did I do that? I multiplied this by 4, and I multiplied this by 4. I just scaled up. I could just as easily write 32 over 64. That's a scale up. That's 1/2 is the same thing as this. But I chose this because of the 8. I want the 8s to match in both of these. So how did I have to get this 2 to match? Well, I multiplied it by 4, so I multiply the top by 4. And then addition and subtraction, once you've got to this space, you don't touch the bottom, right? When you actually subtract this, you have 4 minus 3, which is 1 over 8. The bottom doesn't change. It's like the bottom tells you how many pieces of pizza the thing is cut up into. This is how many pieces you can eat. So of an 8-piece pizza, I get to eat 4. But then I gave 3 of those pieces that I get to eat away of the 8-piece pizza. I still have 1 piece of an 8-piece pizza. The bottom doesn't change. So that's subtraction of fractions, question 7. Question 8. Question 8 is 1/2 divide 3/8. What is this division? What the heck is going on with division? Well, if you remember, division is just flip and multiply. So we're going to multiply and we flip just this side. That's literally it. This is a very strange kind of question, but the math is true, that you just flip and you put the top on the bottom and the bottom on the top. So now we just have a multiplication question, and multiplication just goes straight across both. So 1 times 8 is 8. 2 times 3 is 6. 6/8 is our answer. When we divide, we flip and multiply. So that's question 8. Question 9. Question 9 has to do with fractions and decimals and percentages. So let's go through this. 8%. Well, to get from percent to decimal, you move the decimal point twice. So it was here, I moved it once, then I move it again. So there's an implied 0 there. So 0.08 for the decimal. You might have forgotten that 0, you might have said 0.8, but 0.8 actually gets us 80%. That's too big, that's 1 decimal too big. So for 0.8, we actually want 8%, and 8% is going to be 0.08. Then for the fraction, it's 8/100, like we all know. And then for the and then you can simplify that if you want to 4/50 or 2/25. Those are all equivalent. So that was the fraction. You just put the percentage over 100 to get to the fraction. All right, and for question 10. This one takes a fair amount of work, but in the end, it's just cross multiplying. So 8/6 plus x equals 4/x minus 2. Okay, what does this actually mean? So this thing divided by this is the same thing or the same fraction as this. So how do we solve something like this? When you've got a fraction equals another fraction, just like 1/2 equals 4/x, we can do this thing where we cross multiply. So you could just guess and say x is 8. Or you can say 1 times x, which is x, equals 2 times 4, which is 8. So you cross multiply. You take the top, multiply it by the bottom of the other one, take the top of this one, multiply it by the bottom of the other one, and then you put those on either side. X equals 8. Boom, you're done. This you could have guessed at. This I'd be impressed if you could guess, but you could. So what do? Well, we've got 8 times x minus 2. This times this equals 4 times x plus 6. Cool. So what's the distributive property thing here? Well, you're multiplying this by both. You're multiplying this by both. So we have 8x minus 16 equals 4x 4 times 6, which is plus 24. These plus and minus signs are really, really important. So let's move the x's over to one side, right? Because eventually we want to end up with like x equals something, right? That's where we're going. So let's get all the x's over there to begin with. So 8x minus 4x. Don't forget that when you move something across, it becomes a minus, equals 24, and when we move this across, it becomes a plus because it was a minus there. So we got plus 16. So that's 8x minus 4x is 4x equals 24 plus 16. That's 40. Yep. And so 4 times something equals 40. 4 times 10. Oops, sorry. You could divide both sides by 4. Divide by 4. We get x equals 10 is the answer. So that's a doozy of a problem, but essentially what you're doing is cross-multiplying and then just doing some algebra, then just like putting together like terms, right? So that's the end of the answers for week 1. Hope you enjoyed and hope that was helpful.